Hello everyone. I'm glad so many of you came here just before lunch. Who of you is hungry? Only a few. That's surprising. And who of you is hungry for knowledge? You, yes. I'm glad so many agree on that. So, welcome to my talk, How Unit Testing Saved My Career. So, who of you likes to write unit tests? Only like 5 to 10%. I hope at the end of this talk, this will have changed. So, I'll quickly introduce myself. My name is Annelore, and my career was saved by unit tests. I have a Bachelor of Science in Computer Science and about 8 years of programming experience. And I'm a software engineer at Open Value Switzerland. Open Value is a Java consultancy company with offices at different places in Europe, especially Netherlands, Germany, Austria, and of course Switzerland. So, in 2016, I quit studying political science because I did not see a future for my career with this field of study. I was then looking for another career path and decided to give programming a try. It was interesting and challenging at the same time. I followed some materials from university, and as far as I remember, my big struggles started when learning about methods. First, I only created very, very simple programs where everything was just in the main method. But as soon as I learned about methods and had to do some more complex programs, if I then created a program that did not do what I expected, I had no idea how to work with that. And I was rarely able to find out why. And other times, I almost wanted to forget that, but luckily I was reminded. There were times where I just had no idea where to start when I wanted to try to program something. And I felt like I was just looking at the screen for hours. And sometimes I was then also encouraged to try out something, but also nothing good came out of it. It was then when I was shown unit testing, and this opened a whole new world for me. With this new tool, I was able to quick feedback and check intermediate steps from my program and understand the code I had written better. Before, I only relied on console outputs, and I mostly only printed the console output from the end result. And now I was able to check every little step in between. Moreover, it helped me to learn how I should structure my code better. I personally struggled with how to structure my code in the beginning, and sometimes it was all over the place. But when I learned testing, I also had to start thinking about what input and what output I need, and this meant I was able to create better methods. It helped me to practice splitting up my program in logical steps. And I loved the feeling of being able to understand better what I am doing and less frequently having to ask for help. In order to take you on my adventure, I want to show you some examples. So first, I quickly want to show how I like to set up my JUnit tests. I think it's best if they are small and simple, if it's possible. And it should not be difficult to understand what one specific test does. I also like to split it up with given, when, then, but I also know that a lot of people don't like this very much. I think it's just good if you make sure to, in your team, decide on a structure and stick to this so it is clear how your tests are structured. And I think the most important thing is try to make the tests easy to understand. Here I have another example. I think it's also very important to have clear method names. Here I already in the name of the method mentioned that I expect an exception. And this is really useful because sometimes when you look through tests, it's useful if you only have to look at the name of the test and don't have to read everything. I also find this example important because it is testing an error case, because sometimes it is forgotten that you also should test these cases and not only the positive cases. So I will now show you some examples. I'll have to quickly leave. So I'll quickly go into the presentation mode. Okay, I hope you see it well. So I let ChatGPT create a bad example. And this is just a program that counts the word frequency. So it wants to count which word occurs how often in a specific text. So first it says hello world. Then here it is cleaned. So it means it takes away everything that are not letters. And it also makes all the letters lowercase in order to compare it better. So after that, we have the clean text. And then it is actually really counting the words, and then you get the output. As you see, there are some comments that ChatGPT created, and they are already a hint for me that they should be methods. So, for example, the cleaning the text or splitting the text so you can count them. So we have another example. Where we have a clean text method, a count words method, and a print word counts method. And this was introduced only after it was possible, only while creating tests. So I will also show you the tests. Good. So when creating the tests, you have to think about how can I test it. And in that moment, you then better realize which parts should be extracted into a method so you can test it. So through creating the tests, you then also can create better code. And this really helped me a lot when I was learning to program. So we have like a clean text method that just tests if it's really cleaned. Then we also have a count word method that tests if the words are counted correctly. And there's also a method that tests the full flow, but this one is obviously not that important in order to then split it up into different methods. I can also quickly show you the comparison. That's the comparison like from the good and the bad example. So you again see that here a new method was introduced. Another part was split up in a method. And this one. And only a few little things remained in the main method. So, From the examples I showed you, I want to highlight that testable code often is more understandable code. Moreover, I feel like testable code is often cleaner code. For example, making logical parts, or we call them methods, is not only helpful for testing the code, but it is also one of the clean code principles. I am sure we could analyze these topics very detailed, but let's agree that usually testable code is more understandable and cleaner. When I learned to program, I of course did not know the clean code book, but people that helped me to learn program mentioned some aspects. And I think some aspects of clean code became just second nature to me just by trying to make the code more understandable and cleaner when I was using unit tests. Testable code also gives fast feedback. So you know that you are on the right track. And therefore tests also give confidence. And I am pretty sure that this aspect helped me a lot when I was learning to program. If you learn something new, being confident can help a lot, also if it's only for a small little step where you get some feedback that you are on the right track. And testable code is easier to maintain. If I did not have the tool of unit testing, I might have given up on programming as a whole 8 years ago. So you could really say it saved my career. After that, I did an apprenticeship as a software developer and did a bachelor's degree while working as a software developer. I want to show you that testing can be more than just a tool to make sure that the code does what it should be doing. Like it can do clean code, more understandable code, and much more. Later on, I also experienced other struggles with unit testing. Along my career path, I'd like to show you what I learned in unit testing, and I tried to roughly stay in chronological order of how I learned about these things, but obviously I don't remember everything in the right order, so forgive me for that. So when I learned about unit testing, it helped me to think about inputs, which inputs and outputs are necessary. And I also started to use test-driven development because I often found it easier. And it forced me to think in a more structured way. I quickly want to explain test-driven development, just that we are all on the same page. So first of all, you write the test, and then the test should fail first. Never trust the test that hasn't failed once, because if it immediately passes, maybe you don't even test anything. After you have seen that the test failed, make a minimum code implementation so that the test passes. After that, you can refactor it to improve it, and the test should still pass. A benefit is the code I write when using test-driven development is immediately testable code. And as I mentioned, this leads to more understandable and cleaner code from the beginning. I also love that when I do test-driven development, I have very fast feedback while developing. If you look at the previous example I just showed you, I could have produced a good example from the get-go if I had done it with TDD. And sometimes it is also helpful to first focus on the tests when you have to think about the specification more. So if you have a very difficult specification, you could maybe first translate the difficult specification in tests, and then when you already have these tests, then do the implementation. And then you already have broken down some of the complexity, and while you are then implementing what you have to implement, you have like the test cases that help you to make sure you're doing the right thing. And also sometimes tests are like some part of the documentation because it tells you what it should do. So I love to use the tests as a tool which helps during the development process. I really like using test-driven development, but honestly, I do not use it as often as I should. One of the reasons are complex applications with sometimes too complex test setups. When I was already in the apprenticeship, I encountered more complex setups. Luckily, I then also learned about Mockito. This helped me to more easily create tests without having to understand everything around it. As Mockito helps you to mock the objects you do not want to test, you can focus more on the unit you really want to test. So I'll also show you a quick example for this. So let's go back to IntelliJ. Good. No, wrong shortcut. So, in my Mockito example, we have a weather client. This weather client calls an external API that is called Open Weather Map. But we don't want to test the open client because it calls an external API. We have also the weather service that uses this client we just saw. And this client, so the weather service calls the weather client to get the weather, and he then gives some jacket recommendation. So if it's below 0 degrees, you need a very warm jacket, and if it's maybe below 15 degrees, you still need a jacket, but not as warm, and so on. And if it's very hot, you don't need a jacket and probably stay in the shade. So if we have, so if we then want to test this method, we don't want that the weather client is called every time. So it makes sense to mock it and then just say, hey, I mock the weather client, and when this client is called with this specific longitude and latitude, then return this specific temperature. So we do not have to call the external client. And then we can still test if the weather service gives the right response. Like here, it's you need a jacket. So during my studies, I then experienced another crazy situation with unit tests. At the University of Applied Science, where I studied, we had projects with real customers. And once we received a project that had barely any tests. There was a web front-end and a .NET backend. And after we did some changes, we suddenly heard that there was a second front-end, a desktop front-end using the same backend, and we accidentally broke it. And this was only discovered after we deployed it, as there were no unit tests. I also remember that the code was not very beautifully written, and when we wanted to refactor something, we always feared of breaking something. Especially because it was a student project, we were also very limited on time, so we only focused on the things that we really had to do, and we tried that at least the code that we created met certain quality standards and was covered through unit tests. But still we had to be very careful because it's very difficult to only create new code and not having to touch the existing code. And often we just had to hope that we do not accidentally break something. and yeah, hear from the customer. And usually we only heard from the customer when we really broke something. So this experience showed me again how important unit tests are. When there are no tests, no one feels comfortable to refactor code, and this leads to worse code. Also, we always felt kind of unsure if everything was still okay, because we did not have any feedback. The only feedback we had was if we really broke something. So everyone from my team in this project was actually glad that it was only a student project and that it was over after a year, and it was no longer our responsibility. And we still tried to do our best, but this was not always easy. So I also tried to show this problem in this diagram. So if you have fewer tests, you also have worse code. And worse code is difficult to test, so you also have fewer tests. Then you also have the other issue that sometimes failing tests, they could either be an issue because they are so difficult you don't really know, is the test failing, or did something wrong in the test or something wrong in the code? And it could also be a flaky test, a test that sometimes passes and sometimes fails. And all these tests that maybe could fail could also fail for a reason other than the implementation is wrong, make you lose trust in tests. And if you lose the trust in tests, you also will do fewer tests. So it is like a vicious cycle, and I think it is very important to break this cycle and start to add tests and improve the code base. And you just have to start somewhere. It doesn't work differently. So after this rudder experience, let's look at another tool I learned about, which is very helpful. In JUnit, there are also parameterized tests. Who of you has used parameterized tests before? Oh, I think almost half of the people here. That's great. So here I have a very simple example where I use the CSV source, where I just calculate the square of some numbers, and you see that like this you could already replace 3 test methods, because to do the same without parameterized tests, you would create 3 test methods. I really like parameterized tests because usually you can much easier see at one glance if all the cases were covered and if some cases are missing. And it's easier to see if maybe you also have negative and positive tests, if you thought about all the boundary values. And I think that often developers also rather add an additional test case if they are working on something, because they only have to add, for example, in the CSV source, one more case if they are working on something new. And they don't have to create a whole new method. There are multiple possible sources to make parameterized tests. I also quickly want to show you another example. So I want to show you an example how you can use the enum source in parameterized tests, and I just realized I didn't exit the presentation, sorry for that. So here we go. We have here an enum that defines some user roles. And we have a permission service here. It's a very simple service. It's only for showing the example. So we just have a service that says if you can access the admin panel, if you're an admin or a moderator, you can access it, and otherwise you can't. So what I really want to show you is how you can easily test this with parameterized tests. Here, the permission service test. So you can use the enum source annotation and say which enum you want to use. If you only would use this part here, it would just use all the enum values that you have in user role. But we here added names, admin moderator. So I say, I want that you test this test with every, I want that you run this test once with admin and once with moderator, and it every time should return true. And then here we have the opposite. I also wrote admin and moderator, but here we have the mode exclude. So we want that it runs also this test, but for every value except for admin and moderator, and it always should return false. And I can quickly show you. I actually realized I didn't show that the other tests run, but believe me, they run, and at the end you anyways can get the slides and the code examples so we can verify the tests run, the ones I showed. Unfortunately, I cannot show it in more detail, but you see it shows me it's 4 tests, even though it is 2 tests, but this is because it is run for admin and moderator here, and here it is run for the other 2 user roles, so that's why it's still 4 tests. Why is it? That's interesting. So I was here, right? So moreover, there are other possible sources you can use to do parameterized tests, like value source or method source. My experiences with method source, you sometimes also have to be a bit careful, because I have also experienced that with the method source, it became so complex again that I wasn't anymore sure if the parameterized tests made it even more complicated than without using parameterized tests or not. So I feel like it's always difficult there, and I unfortunately cannot give you like a clear rule. You probably have to decide on a on case-to-case basis. As you see, there's also a link that I put there at the end of the talk. There will be a QR code where you can get the slides, the code examples, and so on. And the links that I put there are also clickable, so you can also look into more detail. So I already mentioned complex test setups a little when talking about Mockito, but I think we have to go into more detail. Who of you has experienced something like this? You have like a strange test and you don't really know, am I testing my code or is it testing me? Okay, only like 5, 6 people. Who of you is scared to admit it? No? Okay. Yeah. Probably most are scared to be scared to admit it. So, yeah. So, yeah, in the situation I am talking about here, like the test setup is very complex, and every time a test fails, you are not sure whether your code is wrong or your test setup is wrong. I find this a very sad occurrence, because tests should be a tool that help you with the implementation. It should give you confidence. it kind of destroys the thing I love about testing. And I started to dread testing as well, even though I really liked it before. And I think it maybe even made me kind of sad a bit, as testing used to be my entry to software development. It made it very difficult and frustrating for me to implement code or do tests in a new project. So in these cases, unfortunately, tests sometimes become an even larger struggle than the actual implementation. And I hope that we all agree that this is not a good practice. For example, I also experienced very complex setups where we created our own mock objects, and sometimes it even felt like we had our entire custom test framework that we had to know to write tests. So you had to learn like a new framework only for this specific project in order to even test it. And I think it is very important to challenge complex setups. If you are in a project that has a very complex test setup, try to challenge it. But you should not say, we shouldn't do it like this, but rather ask, why are we doing it like this? Because I think in the worst case, if it's really not possible to change it, you at least learned how you can, why it is that complex. And I also hope that this won't be the case, of course, but I think it's a good place to start to ask, why are we doing it like this? So you can then ask some questions like, is maybe the code too complex? Should it be broken down so it is more testable? So I think it's like fighting the cause and not the symptom. Improve the code to make it testable, and do not lose time by trying to make an impossible test setup work. You could also think about, could mocks be introduced to reduce complexity, because maybe you want to test too many things at the same time. You maybe also do not have enough abstraction, or you are setting too many things up that are not needed. Also, ask yourself, does the test setup really only contain the necessary things in order to test the functionality I want to test? Or is it also necessary to learn a lot of logic to even understand the test setup, like I told before? And another question you could ask, is it complex because it is an integration test, but should be a unit test? I mean, in rare cases, it is maybe indeed only possible to do a very complex test setup. But I still think you should still challenge it, and having a complex test setup, if it's really not possible differently, should just be like a last resort. So I just mentioned that one of the issues could also be that you maybe do an integration test, but you would need a unit test. Therefore, I quickly want to go over the testing pyramid. I hope everyone already has seen it once, but I think it's always good to have a reminder. So on the lowest layer, we have the unit tests. We should have the most unit tests, and also the tests, they are very fast and stable usually. Then, one level up, we should have fewer integration tests than unit tests, also because they are a bit more brittle. And then on the top, there are the end-to-end tests. These should be the ones you have the fewest in your project. I think often it is also unclear what exactly defines a unit, as it is also subjective to a part. I think the smaller the better, and I think except for setters and getters, almost every small method could be considered one small unit, as long as it maybe has some kind of logic in it. I think as a rule of thumb, a unit should certainly not be larger than a class, but it is also important that this class does not contain too much. This class should follow the single responsibility principle. I also put a link to the single responsibility principle in the sources of this slide, so they are at the end of the slides. If you get the slides, you can also look into this more. So I hope that you are now reminded again of the testing pyramid. And there are a lot more things I could talk about in regards of testing, but I also find it very important that we have some time for questions. So I am already coming to my conclusion. Unit tests are your friends. They make your code more understandable and are therefore also a helpful development tool. And in cases where you do no longer feel like the unit tests are your friends, it is often a problem in your tests, how your tests are done, or the code setup in general. So therefore, challenge complex setups, so hopefully the unit tests can again be your friend. So, as I promised, there's a QR code where you can get the slides and the code. And I am now open for questions. And also, if you have questions you don't want to ask everyone, feel free to approach me if you see me another time at the conference. But yes, are there any questions? So, I mean, some things, it also depends. You're now only talking about unit tests, right? Or also
no,
some...
No, because I'm from middleware, we don't almost do unit tests. Sorry.
Okay. Yeah, I mean, it depends. If you have things that are really only logic in your part of the application, then I would try to mock away, like if there's something that is coming from Kafka, you maybe have like a method that is called and usually calls or gets the information from Kafka, then I would make sure that this is mocked, so you only test the logic inside your thing. But if you do not have any logic and only pass data along, I feel like maybe you almost have to do it differently.
Okay.
But yeah, maybe we can also talk again later in more detail. Then you can maybe explain the setup a bit more in detail. Then I can maybe give more feedback.
Thank you.
I think there's another question over there.
Hi.
Hi.
So my issue is that, so from my experience, the main issue with unit testing is not exactly the technical issue, is how we get across to clients and stakeholders that we actually need the tests. So I'm wondering if you have like a go-to bunch of, points that, I mean, first, if you usually have this issue of how to get the client to, to pay you for the tests, right? And what are a couple of go-to ideas that you try to get across to the client to make them understand the importance of testing?
Okay, yeah. I mean, it's always difficult to explain to stakeholders why you need some time for something if they do not really understand like the technical part. And I think in some way you almost have just to try to explain that it is helpful. But maybe you can look maybe for like concrete examples that have happened where it showed that a lack of unit tests maybe led to a huge issue. I'm pretty sure that there are some examples, but I cannot really think of one.
So maybe it's just my company, right?
Yeah. I mean, no, I think a lot of companies struggle with that because you often have the issue that the technical people, they are aware that we need unit tests, the code quality is important, that these are things we have to invest in. And usually most stakeholders that don't have like a background in IT, they only see what they want to, they only see the feature they are getting. And they don't know, oh, this feature was just done like quickly, and actually there's a lot of technical debt that was built up, or no tests and so on. So I feel like it's an issue you often have, and yeah, I feel like the only thing that helps is trying to explain it, maybe trying to find analogies to think they can understand, to just show them that maybe you can think of like maintenance with a house, for example. Maybe you can explain them, yes, only because we built the house, it's not that it will stay good for 20 years. We also have to do some maintenance. And explain them that the things you are doing is also maybe some kind of maintenance. Yeah, maybe try to find some examples they can understand because they aren't deep in the IT. Yeah, I hope this helps.
Thank you.
Yeah, you're welcome. Yeah, here another question.
Thank you. I don't really have a question, but just something to add to the other question. I think your suggestions are totally good. This could be one approach to take. One approach I like to take is personally to just not explain it, because in my experience, if you write code without tests, it will take you longer in the long run. So, the stakeholders aren't the ones that need to maintain the code. You are the one that needs to maintain the code. So my opinion, you should just not communicate it, in a way, because they don't need to, or they are not really concerned with how you write the software, but more about like what you're writing in your software. So my approach is to just include the tests in the estimations, and then just do it this way, explain to them, it takes, that many story points or hours, whatever you use for estimations, and just build in the time for the tests. It is just important there that you need to have an alignment in your team. If your team, feels that tests are unnecessary, then that's more difficult, of course. But if you have an alignment among your team that you think that tests are necessary and they make your life easier, then just communicate to the stakeholders. This will take so and so much time, and when developing a new feature, and include the tests as well in the estimation. Maybe that gives you another perspective. Yeah.
Good. Are there any other questions? So I don't think so, but as I said, if you have any more questions and you see me today or tomorrow, just feel free to approach me. And thank you for coming.